Hello friends, welcome back to my channel. So before we understand this video, let me share you the small background that where this video was shot and what was the main thing that is to be discussed here. So this video is basically of you can say Mohand River in Dehradun, and what happened at the routine work we were there for the river sampling and collection of the data of the discharge, the water level. Unfortunately, this Hydra got stuck in the riverbed, you can see. So what was supposed to be a routine observation that turned into a fascinating life case study in river engineering, you can see. This Hydra crane got trapped in the riverbed, showing us firsthand how this sediment, the flow, the river hydraulics interact with this heavy machinery. Now let's see what happened and more importantly what we can learn from it. You can see this Hydra is struggling to get out of the bed, this river bed, and the river is in boulder stage. So here we can see that Hydra crane is partly submerged and unable to move forward. So driver is struggling hard at how to get out of this river bed, and water is continuously flowing. Although the depth of the water is very slow, very less, but the slurry that has combined with the water has made the tremendous effect on this movement. So driver could not able to just push out this Hydra out of it. The riverbed here you can say is covered with slurry, mixture of all the flowing water and coarse sediment particles. Since this Mohand River is in the boulder stage in Dehradun, so you can see that sediment size are particularly in the order of cobbles to gravels. So when heavy equipment moves onto such a bed, the ground loses its shear strength. Simply the soil beneath the wheels behaves like quicksand, you can say, and this Hydra becomes stuck. So this is very common in rivers with high bed load sediment. As water velocity decreases near the banks and sediment deposits loosely, it creates patches where the soil looks like solid but actually it's very unstable. So what we have done that this after repeated attempts, when it was clear that Hydra cannot escape on its own, so excavator is brought in for support. You can see that this is the excavator coming in into the riverbed, thus to pull out this heavy machinery, the Hydra. After repeated attempts, it is clear that Hydra cannot be escaped on its own, so excavator was brought to the side. You can see that excavator is crawling down to the position of the Hydra. I hope it is very clear that even it is very easy for the excavator because of its crane belt, this structure, crane belt type of arrangement. It is very easily gliding over the surface and reaching to the Hydra through the tracks, which provides better stability, you can say. So that's why we can say that in general, I'm not quoting always, but excavators are generally more reliable in such type of soft ground conditions. So now you can see that it is just going and it will come back from its and it will try to push. So the excavator is moving forward, it is trying to align itself with the Hydra so that something could be done out of it. And you can say that excavator positioned itself carefully, and when it positions itself, it begins to push. Now it is positioning, and you can say it begins to push the Hydra. You can see how teamwork between the machines is essential here. The excavator provides just enough force to overcome the suction and resistance created by the slurry bed. You can see now the Hydra is able to get out of this. So this highlights the importance of field planning. Before entering a riverbed with heavy machines, we often conduct geotechnical and hydraulic surveys to assess the bearing capacity. But in real life, quick decisions, improvisations are often required, as we see here. Finally, after much effort, you can see the Hydra is pushed out of the riverbed. This may look just like another field struggle, but to us as a river engineer, it demonstrates the sediment transport, the bed shear, the flow resistance, not in equation but actually in reality. So this incident is just more than a rescue of a stuck machine. It's a reminder of how dynamic river systems are. Sediment transport and you can say the flow conditions can change within hours, and it creates challenges not only for our research, but also for the infrastructure and construction work. So field work like this bridges the gap between textbooks and reality, and every incident carries a lesson. So just I wanted to share this video with you. I hope you enjoyed this real world insight into the river hydraulics and sediment behavior. So don't forget to subscribe for more field experiences, engineering discussions and practical demonstrations from the world of river engineering. I hope you enjoyed this rescue of the Hydra with the help of Excavator. Hope to see you again. Oh, he is my friend, Ajay. Anyhow, okay. So I just sign off. We will come up with another some interesting problem. Okay.